This one is what kind of problem? So when I ask that, it's for this purpose. It's because when you start looking at a whole test, there's lots of problems or lots of different types of relationships, right? So big ideas, circle equations, like I'm just going in order. Area of a sector, length of an arc, area of a segment, tangents, chords, and now inscribed angles. So of all of those things, what kind of problem is this one?
Chord.
It's chords. Okay? How come?
You're finding half of the length.
Yeah, and the only thing, well, not the only thing. AC and FD are both chords, right? And then the other two lines are radius. Anyway, so it says AC and DF are the same. Find FH. So this little length. How? Well, what is it? What does anybody know what FH is? It is. You know? Kyron said 2. Well, he did this. Linda's doing that too. It's 2. Yeah. Why?
GC is 2 and they're the same.
Oh, yeah, sorry. GC is 2. Well, AC and FD are congruent, we were told. And since GC is 2, that can be 2, but we have to know that the radius bisects the line, the chord. Remember that theorem? Why did it tell us about the angle? Like, did that help? Okay. I said angle, which I meant arc length, arc measure. So measure of AB is 43. What could you do with that? Like, does that do you any good? She said we could copy the arc of AB to BC. Can we do that? Okay. Let's see, what else can I ask?
You can put 90 on the other side of it.
True. So we know that both sides are 90. Do we have enough information to solve for the radius? How about that? Think creatively. We connect that like that. Where else can you write 43? Yeah, right here. Because remember, central angles are congruent to arc measures, their intercepted arc. Okay, we can of course put the 2 there. So is that enough information to solve for the radius? Using what?
Trig ratios.
Yeah, which one? Here, I'll draw the triangle. Right now we have this situation. 33 degrees, 2, and that's a 90, and we want to solve for r.
Sine.
Good. Equals what?
2 over 1.
Yep, opposite over hypotenuse. Good. Okay, so it's sometimes good to challenge yourself to think through beyond the question, right? All right, so here's some interesting news. All right, why don't you grab your notes because we left off in the middle of a note yesterday. And And let's quickly review about what a secant is. So remember that it's kind of like a chord, only it keeps going. Either both directions or just in one. So the way we drew that. And then we started talking about these interior angles. So when secant lines intersect inside the circle, it creates angles, just like all intersecting lines. But we can relate those angles to the arcs because it's in a circle, which is cool. Okay? And don't draw this, but I want you to think about, like, these could intersect up here really close to the circle, and so we have this like huge arc down here and a little teeny one, a couple of teeny ones at the top. And these theorems still apply. Or it could intersect closer to the circle where these four pieces are kind of similar in size. But it doesn't matter, it's cool. All those angles relate to the arcs, the measures of the arcs. So where we left off was we need to go label the points, just so we have something to reference. So we just call those A, B, C, D. And then if we put, let's just make one of these angles, we'll just call it angle 1. That doesn't really look like a 1. This theorem holds for any of the angles, but specifically, we'll use this one just for reference. Okay, so how many interior angles do you see? Just to check before we write this. We should see 4, right? Like 1, and then there's 2 on the other side, and then 3 and 4. Okay? Here's the relationship that you can apply to any of those. So measure of angle 1 is 1/2 the measure of arc DC plus the measure of arc AB. Now, how could you change that? Let's say we wanted to solve for a different angle. How could you change that? Like, don't change your notes, but what if I wanted to do 2? How do you think your formula would have to change to find angle 2?
Measure angle 2 equals 1/2 measure arc be AD and then BC.
Yeah, good. So it's the 2 intercepted arcs that the angle is facing, right? Well, the 1 and it's vertically. So I guess probably it would be good to highlight those. Like that. So it's just half of the sum. So I want you to think about solving the various ways that you could solve with this formula. And we'll put an example in your notes, but everybody look here, because I'm going to point. I mean, clearly it would be most straightforward to solve for measure of angle 1 if I'm given those 2. So you just add them and take half. But what if I'm solving for arc DC, and I'm given these 2? You see how we can kind of twist this, and it changes the algebra a little bit? Here's what it might look like. Let's say it's 50 equals 1/2 x plus 70 or something. So how would you solve for x in that case? You don't need to write this because we'll put it in an example, but I want you thinking ahead. How do you get x out of there? You have 2 ways, so it might look different depending how you see it, but...
Would you need to distribute the 1/2 first?
Okay.
And then get x by itself.
So that's one way, is distribute the half. What's another way?
Multiply the whole equation by
Yeah.
2 over 1.
Yeah, so we could also get rid of the half by multiplying everything by 2. So if I times 2, that side just becomes x plus 70. Okay? So either one, it doesn't matter which way you do it, but just know that there can be a little bit of algebra involved in solving for one of these two that are inside parentheses. And each of our relationships are going to have that. Ooh, that's annoying. In fact, let's do an example of this before we do the next three, because they're a little bit unrelated. They'll kind of have a similar formula, but the appearance of the problem is different. So something like that. So it's telling us AD is 155 and BC is 61. So what would you do? That's the easier version. Can someone do that for us? 155 plus 60 is 216 half, so 108. What do we label it? Is it a length? Yeah, so degrees. Good. Okay, before we go do our example, this is the next step. So do you see what I mean? It looks different. The formula is not that different, but it looks different on the on the appearance of the problem. So I think let's just put an example of the more difficult version. Are you good with that? Since we just did the easy one and it seemed like that went pretty well. So just one example. If you're not, let me know before we move on. And of course we can make these a little more difficult by a couple different ways. We could do it, maybe make it a quadratic solve. We could maybe do, like, give you a couple other arcs that you have to subtract to find something else, that kind of thing. But let's put a 50 there, I guess, and then let's say measure of angle 1 equals 70 degrees, solve for x. Well, step 1 is identify what kind of situation you have. And because we already titled it, we know it's interior secant angles, but if I just hand you like 15 circle problems, this is going to become critical, right? Identifying which part, like which of the units, sections that we're dealing with. So this is secant angles. Okay, we already knew that, so I'm not going to write that anywhere. So write the correct formula for this. Measure of angle 1 equals 1/2. Is it always going to be 1? No, like think of a problem like it could be angle A or angle CDH or whatever. I almost said CD3. Alright. So arc A plus arc B, I don't know, it doesn't have to be exactly what we wrote. If we call that arc A and this arc B, right? So measure of angle 1 is 70. And arc A is x plus 1, and arc B is 50. You could go, if you had names for those arcs like we did in our notes, A, B, C, D, you could name those, but basically you're just adding the two arcs that the angle and its vertical angle intersect, that's all. Alright, what's a good first step? Okay. So this just becomes x plus 51. All right. We want to get x out somehow. We talked about the two ways you can. Do you guys, after I showed you the two ways, do you have a preference? Do you feel yourself having a preference? My tendency is just to multiply by 2. I'll just put both in here. So we want to get rid of the 1/2. You can either distribute or multiply both sides by 2. So we're going to get 140 equals x plus 51. Do you need to distribute the 2 and make 2x and 102? You need to do that? Like this? Does it do this? No, that would be double distributing, right? Don't do that. So you're just distributing the 2 on the 70 and the 1/2 only. And then the half cancels the 2. And then solve from there, just like that's a normal. Solve for x. Solve for x as usual. So in this case, just subtract the 51. And I think we get 89.
Yeah.
Do you label x equals 89 degrees? Is it 89 degrees? Okay. No, because x is just part of that angle name, right? It's really x plus 1. All right. Good on that? Okay. So for the next notes, we need 3 boxes because you saw I showed you briefly the 3 different versions. So here they are again. This is 2 secants. Here, just look at them and then it'll make more sense when we draw them. Where do these intersect? Like, intersect doesn't mean they have to keep going, but where does that happen? Outside. We just wrote about inside. So this is now intersecting outside the circle. How about this? How would you describe that situation? So this is 2 secants intersecting outside. We already did 2 secants intersecting inside. What is that one? Yeah, good. Secant tangent intersecting. And they have to intersect outside, right? Because the tangent doesn't ever go inside. And then how about this one? Yep, 2 tangents. Okay, here's what I want you to notice before we go write this down. I wonder if I can make this bigger. Okay, big idea. The formula is the same for all 3 actually, as long as you see this. Each of these create a big arc and a small arc. There's the small, there's the big, and this one's more obvious. There's the really big and the small. Okay? You see how each one of those break the circle at a point, at 2 points that create a bigger arc and a smaller arc? Okay? So you can read here, they're using D minus C, but big minus small. It's just half of big, but now it's minus instead of plus, which could be confusing. Okay? But otherwise, as long as you can see those different sizes of arcs, it's the same. So we'll put that in as a formula. And I don't know, I guess we can do an example. So now we're dealing with exterior angles. It's probably worth splitting that from what we just wrote. I gotta write this better, sorry. So secants intersecting outside. So just draw two secants intersecting outside. And then if you're using a highlighter, and if not, that's fine, but let's go ahead and highlight the two arcs. So we have a bigger one and a smaller one that kind of sit inside the angle, or in between the two secants. All right, next is secant tangent. If you are using colors for your highlights, try to keep the big and the small the same color in each of these so that you have that reference. All right, I'll let you get caught up before we write the formula. So 1/2 big arc minus small arc. Is everybody seeing the arcs created by the lines? I think sometimes people miss that those tangents create a point where the point of tangency is that breaks the arc itself up into pieces. So just keep your eye out for that. I think maybe we could do our quiz on this stuff and let it be the circle of joy. That'll be our quiz. How about that?
Mm-hmm.
Yeah, he's like, yeah. What?
It's a horrible.
That's a good idea. That just kind of covers everything. Well, all this kind of stuff. Do you feel like you need an example for these, or are you okay with it? I mean, it's the same. The example would run exactly the same as what we just did, except it's minus instead of plus towards the end. Otherwise, it's the same. So here's some example looking problems. What? That says write a proof. We haven't done that in a long time.
Are we gonna need to do that?
You've missed it.
No.
Maybe that will be your test. No? Ooh, I just gotta look up death from Bailey. Look, there's 2 right in a row. Alright, so which case is this? Not that it matters, but which one is it? Yep, secant tangent. So notice we're given, it says what's the measure of angle ABD, which is that angle. But we're given that arc over there. So that's kind of weird. Do we need that? Yep. How are we going to find that measure? Well, we know the measure of angle ABD is half of what? Let's be specific to the labels in this problem. Half of arc DA or AD minus arc
Oh,
CA, yeah. Honestly, these should have measures out front. Okay, so the big arc is DA and the little arc is CA. So why is that there? Why is the 139 there? Yeah, we don't have the small arc otherwise. So measure of arc CA is what? Like how to... Huh? Okay. So subtract these 2?
Yeah.
So 139 and 151. It's 290, I think. So 70. Can someone check? I think it's 70.
Oh, yeah.
Okay. So now we can put that right there. And then it's just a matter of plug and chugging. Anybody working on that? Silvana?
81.
That's not 81. Yeah, I guess you just didn't have it. I'm gonna lock you out, buddy. Alright. Yeah. So which situation is that one? Yep, 2 secants intersecting outside. So same measure of angle J equals 1/2 arc JM minus arc KM. Okay, we just fill stuff out that we know. So we know that's 34. And JM is 6x plus 6. And be careful on this one, because you can't just write 3x minus 5. Why? This is an algebra thing, not a geometry thing. If that helps. So let me ask you, what's being subtracted?
Well, 3x minus 5 can subtract.
Yeah.
Subtracts plus 6.
So that actually does make a difference. Be careful. We're subtracting that whole second expression, not just the 3x. So if you don't put parentheses, you only end up subtracting the 3x. Okay, so rewrite, we're gonna combine our like terms in here. So we get 6x minus 3x, which is 3x. And then 6 minus negative 5. What does that become? 11. Okay? And then what? What should we do at that point? Yeah, or you could distribute the half, but then you end up with some weird numbers, so probably easier to multiply by 2. So that distributes to the 1/2 and cancels it. So now we just have 3x plus 11. Okay, and then subtract your 11, you'll get 77. And divide by 3. And I don't know, what is that? 2, 5, 25, and 2/3. Good? Did I do something wrong?
I think you added the 11.
I did. I said subtract, didn't I? That's pretty weird. I actually added 9 and not I went the wrong way. Oh well. That's a whole number. Let's see. 54 is 18, 19. Hello, what's going on? Well, it's 19. I'm not sure what the problem is right now, but.
It's 19.
There it goes. Okay. How'd that one go? How about the geometry part of this arc minus that arc and getting all that set up? How about the algebra part of distributing a 2? Did that go okay? Okay. How many of you caught that you needed parentheses around 3x minus 5? So be careful on that. That would throw off your answer. All right, so I handed you a paper. Notice that it is multiple choice.
What paper?
Did I not give it to you? Sorry.
No.
It is multiple choice, but obviously you still need to show your work. So let's just work on that.